definition of a derivative. I'm going to draw some sort of graph here. Who cares? Yes? Right now we're going to do this. Otherwise, it's too chaotic, so we're going to stay with topics. You have a spreadsheet with the topics on it. So do those problems and then ask questions on those. So I have 2 points here. Okay, Alex, what do you want to call this one? Nope, it's A, comma, f of A. And this is B, comma, f of B. And you should know the definition of a derivative because it's really just the slope of the tangent line. That's all it is. So what is, we'll do rate of change while we're here. What is the average rate of change? What's the average rate of change, you know? Yeah, f of b minus f of a over b minus a. So if they ask for the average rate of change, they're asking for this. It's the slope of the secant line, just the endpoints. Mm-hmm. I'm doing the definition of a derivative. But rate of change fits in there, so I'm going to throw it in there. That's this ivory-looking one. It's got all your review notes in it. I don't know why I don't seem to have any extras either, but I should. Okay. What is a derivative then? Okay, Austin, what are we going to do with this point right here? We are going to drag it along the curve until these get really close. Okay, Austin? That'll be infinitely close. Basically, you still do have 2 points because remember, this is a limit, and limits we don't care about what happens at that point when they actually join up. So what is an instantaneous rate of change? Now, they could ask you to do something with the definition of a derivative. No. What is the instantaneous rate of change? It's the limit as b approaches a. I did the alternate definition by accident. That's okay. Of f of b minus f of a all over b minus a. Where are you going to see this on the exam? You're going to see this, for instance, like x squared minus 4 over x minus 2, and you see a limit as x approaches 2. Because the derivative at a single point is not going to exist. It's going to be indeterminate. Now, do you recognize that as a derivative? This is f of x. This is f of 2. And this is x minus 2. So f of x is equal to what? What's f of x? X squared. Where's the value we're going to find the derivative at? C equals what? 2. Now, you could do the limit with L'Hopital's rule, or you could do the limit with factoring, or you could just take the derivative. So I recognize that's the derivative. So it's f prime of x when x is equal to 2. What's the derivative of x squared? You know that. It's 2x. At x equals 2, so the limit is 4. So we did it with factoring, we did it with L'Hopital's rule, and we did it with knowing it's a derivative. That one's not as bad as something that could happen. Maddie? I just made it up. I just made it up. I just said, let's take this for example, x squared minus 4 over x minus 2. There's another form for a derivative, the one you like better. My science in me came out there because I like the regular slope formula. So let's do this one. What's the other form? We called this C. So this was what? C comma f of c. And then we put another point over here, and we said this distance was h. Do you remember this now? So what's this x coordinate? C plus h, and this is c plus h, f of c plus h. Remember how to find the slope there? What's the average rate of change? Not average value of the function. The average rate of change is just the slope. So when they ask you for the average rate of change, they're just asking you for the slope at the two endpoints. So it's easy. And if we want to find some problems, we can. So what is that going to be? F of c plus h, it's the change in the y's minus over the change in the x's. Well, it's c plus h. I like to write that, minus c. You're right, that's just going to give you h, but I see slope now. Okay, Andrew? I see slope. So it's the limit. Now, that's the average one. What's the instantaneous one then? What's going to happen to h? If I take this point here, and I'm going to drag this down the curve, what's going to happen to h? It's going to do what? Go to 0, isn't it? Isn't h getting smaller and smaller? Remember doing this? Yeah, we did this a long time ago. So it's the limit of this expression I have here as h goes to 0. And that's f of c plus h minus f of c all over h. Do you remember doing that? We did a lot with it. You didn't like it. You didn't like the limits. And then we taught you the shortcuts. You just have to know those. And unless you specifically ask me for something, doubt I'll review them. So where would this appear on the exam? They might have you do this. They might have the limit as h goes to 0 of the sine of 2 plus h minus the sine of 2 all over h. And I know you don't know your trig formulas. I don't know them either. So I recognize that. Yes, Taylor. The same one, yeah, this one? Up. The other form. It's just f of b minus f of a. Or f of x minus f of c. All over x minus c. Same thing. Mm-mm. Yeah. Because if I don't recognize it's a derivative, I can use L'Hopital's rule. But if I recognize, maybe I'd just rather use a derivative. Oh, because this is f of x minus f of c all over x minus c. It's just the slope. That's the change in the y's, change in the x's. Because I had a lot of experience. That's the reason why I recognize it. So could you do L'Hopital's rule or could you factor? Sure, you could. Yeah, you can. Nothing wrong with that. The L'Hopital's rule says, well, I get 0 over 0. That's the first thing. And then you can do L'Hopital's, which is the derivative of the numerator, which is 2x over 1. And you're going to take the limit as x approaches 2. That's still 4. But what about the next one? What about this one? Only if you get 0 over 0. Oh, that should say h, sorry. H goes to 0. Do you recognize that? This is f of x plus h. This is f of x, or c, doesn't matter what you want to call it, all over h. What's my function? This is x plus h. What's the function? The sine of x. And what's my c value? Where am I taking the derivative? At what? No, not 0. 2. X plus h. If you want to call it c, you may call it c. So c is equal to 2. So I can do that easily. So that's the derivative of the sine function. So f prime of x, what's the derivative of the sine, you remember? Cosine. And I want to find f prime of 2, so it's the cosine of 2. It's up to you how you do it. Could you use L'Hopital's rule? Because you're asked to find the limit. So if you have to find the limit, there's a variety of ways. I could expand sine of 2 plus h, but I never remember that trig identity. So that's not a good option for me. It's equal to the cosine of 2. Can you do L'Hopital's rule? Let's find out. If I put in h equal to 0, do I get 0 over 0? Okay, using L'Hopital, it's the limit as h goes to 0 of the derivative of the numerator. What's the derivative of the numerator? Cosine of 2 plus h. Derivative of sine of 2 is 0. Derivative of h is 1. Let h go to 0, and I get the cosine of 2. Yeah, there's 2 ways to do it. There's 3. The third way is to expand that more time than I want to spend on. They both work. But sometimes in a free response question, they might say, using the definition of a derivative, show that something's true. And that's how I actually show that the limit of 1 plus x to the 1 over x is actually equal to e. I need to use the definition of a derivative to do that. Okay, that's what a derivative is. Now, let's say this again. I said it before. But if the function's differentiable, what has to be true about the function? Can there be a break in the graph? No, you have to have a continuous function. And you know the 3 things for continuity. I don't have time to review it. It's in the video from last week. And we did the problems. You go and do the problems from last 2 years, I think. They had that on exam using the definition of continuity. So you have to have those 3 parts we've talked about. But what if you have a continuous function? Do I necessarily get a differentiable? Does that imply differentiability? Is every continuous function differentiable? Give me an example. All I need is an example. Absolute value. F of x equals the absolute value of x. So it looks like this. Okay, Val? It's clearly continuous, but it's not differentiable because we have a sharp corner. Okay, it's the beginning of chapter 3. We spent a lot of time on derivatives. We had to do some rules for limits and such. I think I only have the one definition on there. Both should be on there. Okay. Pardon? Is it yeah, which number is this? 1997? 1997. You can just write it down. 79. It's the limit as h goes to 0. This is a great problem. Thank you, Andrew, for bringing this one up. Well, I have them worked out. Which of the following must be true? F is continuous at x equals 2. These are hard, by the way. I never find these easy. F is differentiable at x equals 2. And the derivative is continuous. At x equals 2. Okay, it says that the limit exists, which means it is the same from both sides. Well, it said the limit's equal to 5, right? So if this limit exists, is this continuous? Yeah. Yes. So we know 1. True. Is it differentiable? Do you recognize that? That's the derivative. See, that's what I'm telling you, that you have to know what a derivative is. This is f of c plus h minus f of c all over h. It's that form. And they're saying that this limit exists. It's 5, so guess what? It's differentiable. Now, they say which ones must be true. It doesn't say the 3 can't be true. It just says, does it have to be true? Is the derivative continuous? I don't know. I don't know. So I just don't know enough to say 3 is true. Is the answer 1 and 2? Yeah. I don't know what C is. 1 and 2. Not enough information. It might be true. I don't know. This is the derivative. If the derivative exists, it's differentiable. And if it's differentiable, the function must be continuous. But I don't know about the derivative. If the derivative is continuous, the function's continuous. I don't know, but I need to know more than that. I have to know maybe what the derivative is. Pardon? No, that's the derivative, which means at 2, this derivative exists. That doesn't mean that the derivative is continuous there. That's hard. So that's one where you have to use the definition of a derivative. And there's a whole bunch more. Everything is tested. The definition of a derivative will be tested. It'll be a multiple choice question or it'll be free response. Okay, let's go on to the next topic, which is F prime, F double prime. I'm just going to check. Oh, I'm on the same page. Right? F prime. What does F prime tell us? That's the first derivative. I'll actually model it with what's on the packet. What does F prime tell us? That's the first derivative. If you forget, draw a picture. Here's F. What is F prime? The slope of the tangent line. Tells us a bunch of things. What's true about my function here? It's increasing, isn't it? What's true about the derivative? No, it's not increasing. Derivative is positive. So f of x increases. That's all you get from the first derivative. Well, might get some other things. We get a derivative test. What if f prime is less than 0, Andrew? This one's less than 0. My function is decreasing. Okay? Remember that? Now, what if f prime changes sign? It doesn't matter if it's undefined or 0. It just has to change sign. What if f prime changes sign? Does f prime change sign at this point? Positive, negative. Does it change sign there? Yeah. What's special about that point? It's a max or it's a min. If f prime here is going to be 0, but if this changes sign, it's going to go from positive to negative, then we have a max or min. In particular, if it goes from positive to negative, is it a max or is it a min? In particular, if this is positive here and then negative here, is that a max, relative max, or relative min? It's a relative max in this case. What about down here? It's going to go, f prime is going to go from minus to positive, and so it's going to be a minimum. So guess what test that is? Remember? First derivative test. Does the derivative have to be 0 to find max or mins? So you be paying attention. This is it. 3 weeks. This is it. All we have. What about the absolute value function? Is this a minimum? Is that a relative min? Yeah. Why do you say no? It looks like a minimum value to me. Remember, we're talking about the minimum value of the function. What's the slope? On the left, it's what? Negative to positive. So when you look for max mins, does the derivative have to be 0 or could it be undefined? Could be undefined. F prime need not be 0. Because some of you are going to make that mistake in the exam. And you're going to say, well, that can't have a max min there because the derivative is not 0. No, the derivative is either 0 or undefined. In this case, it's undefined. So that's this guy. What has to happen to have a max or min? F prime must change sign. Is that okay, Andrew? Now be careful if you're given a table of values, you guys, because I can think of this. Here's x, here's f prime, 0, 1, and 2. Does that guarantee I have a minimum value there? Let's make it 0. Or maximum value. Could it be a maximum value? Actually, 0 undefined doesn't really matter. Well, you know what? I suppose it could be, but does it have to be? What happens between 0 and 1? I don't know enough information. Right. My function is going to be increasing at 0. At 1, it's going to be 0, and at 2, it's going to be going down. But could it be doing something in between there? Why not? I don't know anything about at a half. At a half, it could be negative. And then it could go back up here. I don't know what it's doing. So if you're given a table of values, unless you know this is a continuous function, you know a little bit more information, you got to be careful with that. Because I've seen it with the second derivative. Let's make this f double prime. Is 1 an inflection point? Remember inflection points? F double prime must change sign. I don't know if it's an inflection point. I know it's concave up, concave down, but that may be, who knows what it is. The function could have increased, then decreased, and then leveled off, and then continue to decrease here. This is at 1. I just don't know. That's the problem. Okay, what does f double prime tell you? I kind of got into that by accident. What's f double prime tell you? If f double prime is positive, then my function is, Carter, do you remember? If the second derivative is positive, you are happy, right? You're concave up. If the second derivative is negative, we're all getting a little negative about the weather because it's getting a little old. That's right. It's concave down. Where do you get inflection points? What's it? No it's. Okay, do we have that down? No it's. F double prime does what? No, I want to be better at that. Has to what? How about just changing sign? That's it. Second derivative has to change sign. The slope of the slope. That's the slope of the slope. You can do increasing, decreasing, and it's okay. I never taught it that way because I think this is easier. It doesn't have to equal 0. Has to change sign. F double prime, that's a really good question, is either undefined or 0. Because everybody thinks that if the derivative is undefined, that's not a candidate. Yes, it is. So both first and second derivatives, they're going to be 0 or undefined. Okay, and the point's got to be on the graph. We have another problem here. I gave you an example of f of x equals 1 over x. Do you remember what that looks like? Looks like this, right? This is concave up. This is concave down. Is there an inflection point? No. The point has to be on the graph. No inflection points. And if you think about it, that makes sense. Function, the point's got to be on the graph. I'm doing great here because we can do some problems after we get through the basic things here. We could even get into related rates. Okay, what is the max-min existence theorem? There are a certain number of theorems you have to know. This is one of them. This is the one everybody doesn't want to know. I don't know why. Now, when you are asked for a maximum value, they're asking for the value, the y-coordinate, and they're asking for the absolute max, unless they say relative or local. I'm lazy about it, but they're not. Do you remember this theorem? Hey, Carter, put your phone away, please. This is the only time you get with me, and you really want to watch my video again? Not me. What do you have to have for the max-min existence theorem? What has to be true about the function? Must be continuous on a closed interval. So we'll call it AB. If I have a continuous function, okay, guys, on a closed interval, then I absolutely guarantee this will happen. This is a guarantee. I like guarantees. F of x will have both a maximum and minimum value. And that's an absolute. Whoops. So if you don't know this theorem, make sure you know it. Taylor. Then there's a max and min everywhere. It's kind of a trivial case. They won't give you that. So when they tell me I have a continuous function and that the interval is closed, and I start seeing in the problem there's a max or min, then I know I can use this theorem. And usually this theorem is the best way to do it. But there, like recently, there was one problem where it wasn't the best. So I didn't like that. Now you may not use your graphing calculators to find max and mins. If you use your graph to find max and mins, then you will not get any credit for it. You have to show the calculus. You can use your calculator for n deriv, fn, I, and t. You can use it for zeros and intersection points. Not to say they're going to say you can't use your calculator if it's in the calculator section, but you must have the calculus. Okay, on the free response. You're right, there's no control, but they'll control it. They'll figure out a way. Okay, so where are our candidates? Okay, can we finish this theorem first? Where are the candidates? Where will the max mins occur? Now, just because you're a candidate and we have elections coming up doesn't mean you're going to win. The person with the most votes wins. But we have candidates. Well, that's real president, but not here at school. Majority. I was referring to school. Okay, where are the candidates? And where? There's three places to look. Brock, do you remember where we're looking? Taylor? Endpoints? Okay, guys, and I've seen often it's endpoints, by the way. Where else? Andrew, do you remember where else? Well, then you should be writing it down. F prime is what? 0. Just think about it. That's a max. I could also have a max here. So where F prime is undefined. Yes. Okay, remember what we called those? Where the derivative is 0 or undefined, we call them critical points. Okay. So first thing, I have a continuous function on a closed interval. I know I have to have both a max and min. I know that they'll occur at the endpoints or when the derivative is undefined. So guess what? I got to find those. And how do I know whether I have a max or min? What's the last thing you do, Carter? You should be paying attention. If you don't know, evaluate what? Not the derivative. F of x at all candidates. And the candidates with the most votes wins. And you will find both a max value of f of x. Make sure you answer the question. Now, why is f of x? And a minimum. Even if it's just a line with a slope. Okay, so we're going to do one of these problems. I could use the max min existence theorem if it applied, but it doesn't apply. This is 1997, number 82. Okay, so I got to copy it because I don't have mine. Y equals 2x minus 8. What is the minimum value of the product of xy? Again, no matter what, even if we don't have a closed interval, Even if we don't have a closed interval, it doesn't matter. I still am looking for the max and mins at the same places. They're relative. They might be absolute, and you have to know what it looks like. Okay, I want the product of x times y. What's x times y? That's equal to x times my y value, which is 2x minus 8. I want the product, it says I want the minimum value of x times y. So I'm going to call it m equals x times y. That's a good question. So this is the this is the optimization problem. I have never seen an optimization problem in the free response, not where it's major, because it's here. It is tested, 2x squared minus 8x. Now, where are the candidates? I know what it looks like besides. Do I need calculus? There's multiple choice. What is that shape? It's a parabola. So I know it looks like this. Where's the minimum? At the vertex. Do you know how to find the vertex? Easy way? I mean, we could take the derivative. It's pretty easy to take the derivative. You don't even have to convert to vertex form. All you have to do is find the x-intercepts. So 0 equals 2x. Let's factor out a 2x, and it's x minus 4. So the intercepts are at 0 and 4. Guess where the vertex is? Halfway in between. Now, that would not be acceptable on the free response because it's not calculus. But what's the x value going to be? It's going to be 2. Let's do the calculus. M prime is equal to 4x minus 8. What's true about the derivative at this point? 0 equals 4x minus 8. And so x equals 2. But let's answer the question. What is the question asking? It says, what is the minimum value of the product? Now, if they ask you for minimum, you wouldn't have to justify it because obviously that's what it's going to be. So if x is 2, what's the y value? Y is equal to 2 minus 8. So it's 2 times 2 minus 8. So what's that give you? Negative 4. So y equals negative 8, and the product is equal to, no, it's negative 4, right? Oopsie, where am I? Yeah, it's negative 4. He gave me the answer, and I just picked up on it. Minus, this is minus 4.
Yeah, I was going to say.
Get in the right place. The answer is negative 8. But let's look at the choices. That's the answer.
Yep,
the choices are negative 8, but they also have negative 4, and they also have 2. So you have a couple distractors there. Because it's asking not for the y value, but it's asking for the product. Answer the question. Answer the question. The day before the exam, I'm going to remind you, don't use the word it, and answer the question. Yes. Right here, what comes out of both of those? 2x. Because it says find the minimum value of x times y. This is y, and multiply by x. Don't make it hard. Yeah, I think that's the thing. Also, if you notice when you do the problems, especially if you do the multiple choice, you're going to say, some are pretty hard, but most of them are not that bad. Don't make them hard. No. You have an hour and a half for each multiple choice. Okay, so then that is an hour and a half times 4. That's all I got. You have 55 minutes for 28 questions. So it's about 2 minutes a question. 4 exams I have, yes. That's it. Yeah. 97, 98, 2003, 2008. You need to practice. Our scores on the multiple choice are lower than the national average. We excel on the free response. And they're equal weight. So what's your question? Oh, I don't know what you're trying to say, but you need to do these. So just budget yourself. A half hour every night, you will get stuff done. Start with 2012 and work backwards. The actual AP exam, but that's not what we're doing. We're preparing for it.
Have 4 multiple choice sections?
No, you have 2 multiple choice sections. I said there were 4 multiple choice exams. Okay, first derivative test. Let's get this done. We're almost done, actually. And I've already talked about it, but let's do it again. What's the first derivative test? Because the second derivative test they can force on you, and they will in the probably the multiple choice. First derivative test, this is f prime. If this is 0 or undefined, if the sign changes from plus to minus, I don't memorize it. It means my function's increasing and then decreasing. Or it could be increasing and then decreasing. Doesn't matter. So some local max or local min? Taylor, what is it? Local max or local min? Look at my picture. Max. What if f prime at C, it could be 0 or undefined, goes from minus to positive? Carter, what's that going to give me? I forgot that. Local what? Min. So I just think through it. Have I memorized much except for the max min existence there, which actually makes sense if you think about it? Yes. Okay. That's the. Now, what's the second derivative test? That's the one that might come back and haunt you, and it will be there somewhere. The second derivative test. You look at f double prime. So first you must find the critical points. Okay, that's where the derivative is 0 or undefined. Should I write that? Might as well. F prime equals 0. F prime is undefined. Then you find the second derivative and evaluate it at the critical points. So you're going to get a value. If you get 0, you know nothing. If f double prime equals 0, you know nothing and you can't use the test. Sometimes tests fail. Then I have to use the first derivative test. But if f double prime is positive, then that means at that point my function's concave up. So this is a minimum. Does that make sense? Remember this now? What if f double prime is negative? That means my function's concave down, and I have a max. I should say of C. Is that okay, you guys in the back? Remember that? They're going to ask you that. They might only give you the second derivative and the critical point. I've seen it. I just don't remember. You don't need f triple prime. Just the second derivative. Guarantees it. Then you can go ahead and read through here about what's true about derivatives at sharp corners or vertical tangents. If the function's continuous, there's some things there. Then we have the rate of change. Instantaneous rate of change, which we've done. Secant is the average rate of change. And I threw an average value of a function. And I did that because they look the same, and actually there are some things that are the same. Instantaneous rate of change that is written down equals the slope of the tangent line. Whoops. Average rate of change, so don't read fast, is the slope of the secant line. The average value of a function. Okay, they sound all alike, but they're not. Instantaneous rate of change, average rate of change, and the word that's going to throw you off is average value of a function. Okay, guys? Average value of a function. Be careful when you see the word average. It could be one of the two. Do you remember how to find the average value of a function? That means you would add up all the y values and divide by how many you have. Well, what does it mean in calculus? We integrate from a to b of f of x dx, and we divide by how many we have, which is the same as the width of the interval. I can prove to you that they are the same things if you want. And there's a connection between those. And everything depends on the context of the problem. Let's look at velocity. Case 1. If I want the average velocity, well, it depends on what I'm given. Okay, guys, this is critical right here. Okay, guys? If I want the average velocity and I'm given the velocities, these words match. You want a little quick way to do it. We integrate our velocities. Okay, guys? T1 to T2. And divide by the width of the interval. What is the antiderivative of the velocity? In this case, it's the displacement from T1 to T2. Now, you guys, I've talked about this before, but I'm still not sure that you've seen it. It took me several years to connect in my head. Okay, Carter? This is S of T2 minus S of T1. Put that away, please. Over T2 minus T1. What is that? Taylor, what is that? No, that's the change in your position divided by your change in your time. That's your average velocity if you're given the positions. So one is in integral form. This is integral form, and one is in slope form or derivative form. So if I'm asked for the average velocity, I'm given my velocities, I'm going to integrate. If I'm asked for my average velocity and I'm given my position, it's just the slope. That's it. That's all it is. They're the same. It's the mean value theorem for integrals, mean value theorem for derivatives. So that's what's on that page. Yeah. Is that enough? Kind of nice. Are we done? No. Okay, guess what? We got through what I wanted to get through. So work on average, work on derivatives. Look for F prime. Look for max mins. Easy to find. You have 2 spreadsheets that tell you where everything is. So work on those. If you don't work on them, time is going by fast, you guys. It's important to be working. Yeah.
Wait. So recording.